Hello and welcome back to Friday Minis. Cache. This is a term that is in use in several different places, and in their individual contexts they have slightly different meanings. But at the same time, there is something similar among all the different definitions. Cache is essentially when I save some information, as a copy in a place that I can access quicker. Because of this, I don't have to go back, to the original place where the information comes from to do a slower fetching of the same information. So there is something predictive in the nature of cache. What I store in cache are the things I expect to be loading up next or sometime soon in the future. That's why I put it in this place that is quick to access, so that hopefully that request is going to come along soon and I can just serve up the cached copy, which is faster. So yeah, that's the idea. Cache exists whether we are talking about file systems, retrieving things from the internet, even on your processor. And that is the version that we're going to take a closer look at today. Essentially, for your processor to operate properly, it needs to go to RAM and fetch things like program instructions as well as the data it needs to work on, so that it can actually do its thing, right? And it'll push its answer back to RAM. But here's the deal, when we're working at the scale of CPU speeds, turns out RAM is too slow. For your CPU to go to RAM and request for information, that's something that could create a bottleneck. And that's where cache comes in. Your CPU cache is essentially a small amount of memory on the CPU itself. Whenever it fetches things from RAM, it tries to fetch a little bit more and put that stuff in cache. Again, going back to the predictive nature, it's going to fetch things that it believes is going to be used soon. And so, when that comes along, it can fetch it from cache instead of going to RAM, and thus save you some time. What is interesting are some of the predictive techniques used to decide what we want to preload into cache. I'm going to talk about 3 of such strategies today, but clearly there's a whole lot more out there. It is interesting to note that these are heuristics. That means, these are just smart guesses. The terminology I'm going to use here involves the word locality, which simply means nearby. Basically, near enough for me to believe that it's something that I'm going to be using soon. And turns out, locality can be expressed as a few different types. Firstly, there is temporal locality. What that means is, if I'm working with something now, there's a good chance that I'll come back to it later. So something that's being worked on now will get cached, so that later on, if I decide to come back to this, it's in cache and I can access it quicker. There is also spatial locality, that is things that are physically nearby. Usually when we're doing something like looping through an array, what we'll do is we'll go to subsequent memory addresses, right? We'll go to one address and we'll go next. So if your CPU believes that this kind of behavior is coming up, what it'll do is it'll pull the whole chunk of memory, in a contiguous block into cache. If you're going to go next, that's great because all of it is in cache and we can do that really quickly. That is spatial locality. There is also branch locality. And here's the idea. Previously we were talking about data, now we're actually talking about program code. Remember, at this level, program code is also just numbers in RAM, right? And the idea is that, again, we're doing the same thing. We're going instruction, next instruction, and so on. But sometimes we'll run across an if statement, or perhaps even the end of a loop, which will basically branch us. It'll make us jump to a different place. What we can do is we can predict whether or not a branch is going to happen. For example, if we're talking about a loop that goes 100 times, well, chances are we're going to have to jump back. So what happens is, I can grab the instructions that are near the top and keep it in cache, so that, when we do actually jump, I don't have to go out and refetch those instructions. So that is why we use the cache to handle code, to handle program information instead of data. So there you go, these are just 3 examples of cache and locality, and how things like our CPU is smart enough to predict what you're gonna do next, and as a result, speed things up. That's all there is for this episode of Friday Minis. I hope you've gained some insight today, but until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.